What's up, guys? Welcome to another course in my channel. In this time we are going to study a little bit about Redis database. Okay, you're going to understand why is this database so required nowadays. You're going to understand its architecture and what is the main difference between this type of database and the others. Okay, in this channel you probably already took a course about MySQL, that is a relational database. You already took at least one lesson about MongoDB, right? The introduction about MongoDB, that is a non-relational database, and Redis is also a non-relational database. But I make a point bringing and providing for you a Redis course because different from MongoDB, Redis is a in-memory database, right? MongoDB is way faster than MySQL because it's a non-relational database, all right, and it has like a built-in caching structure to retrieve data fast. But Redis is different because Redis is an in-memory database. The data that we store in this database, when it comes about the infrastructure, is not stored in the disk of a server, of a computer. Is stored in the memory. Okay, so it becomes way faster to access and to retrieve data. Okay, so you can see that this definition here. Redis is an in-memory key value NoSQL DBMS in long terms, designed for speed, scalability, and real-time data processing. So when we talk about speed, Redis is way faster than MongoDB and MySQL or any other database. When it comes to scalability, we can use Redis to store many types of data archetypes. Let me put it this way, and you are going to see soon how these archetypes work. And real-time data processing, because the data is stored in the memory and it becomes way faster to process, to manipulate, to access, to retrieve, and so on. Okay, so I brought here an example, a graphic example for you to understand it better. So in one side we have the disk-based databases that are the common databases: Oracle, Postgre, MySQL, even MongoDB, right? And the other side we have in-memory databases. In this case we're talking about Redis. Okay, so these are literally the physical devices that stores our data through our databases. If you're using MySQL, you're storing in the hard disk of your machine or your server or your servers. Okay, when you use a in-memory database, you're storing here in the RAM, in the random access memory, in this device right here, right? So this RAM, the retrieving time, the access time, the latency is pretty faster. Okay, it's way faster than the disk. You don't need to read and find in the memory. The access are mapped. And one thing you need to understand is in the case of MongoDB, our non-relational database, our preferred non-relational database, it's stored in the disk, but it has like a mapping for the memory, okay, for this device right here, and it becomes faster than the other classic and traditional databases. So MongoDB is faster because it has a mapping, a caching technology, let me put it this way, to turn our data access faster. But there's nothing like Redis when it comes to fast access to data, okay? So this is why I make a point bringing this course for you. Maybe you think we already have a course about a non-relational database, that is MySQL, and we already have a course about a non-relational database, that is MongoDB. Relational, that is MySQL, and non-relational, that is MongoDB. Why do I need to take another non-relational database course? Because in the case of Redis, this infrastructure allows us to use it as a solution for things that both MongoDB and MySQL are not recommended for you to use, okay? So let's dive in to understand a little bit better about these solutions, okay? So the first solution is caching layer. When you build applications that has large volumes of data and large volumes of users accessing, retrieving data, manipulating data, right? You might face a situation where you have to access or even store, in most cases, access, okay? You have to access many times the same data. So when you build a caching layer, you store this frequently accessed data, in this case into Redis, to avoid hitting the database repeatedly, okay? So I think I wrote it, I made a mistake writing this sentence here, but we store frequently accessed data to avoid hitting the database repeatedly, okay? So instead of every time we need that data, we access the database, we can access the caching layer. And this caching layer, we can use Redis to build, okay? With Redis, we build a caching layer to store in the memory this data to access frequently, okay? This is one of the use cases. This is one of the solutions, and everyone, most people think that Redis serves just for this purpose. But Redis serves for many other purposes. I brought today 4 more purposes, so let's see them. Session managing, for example. We can store user session data instead of keeping in memory or database. So instead of creating the session and keeping in the memory or storing in the database the data of the session of the user that is using our application, right? We can simply use Redis. We can store in the database that is in the memory, okay? We can store in the database that works in the memory instead of the disk, right? So we're not just using the memory that the application is using, let me put it this way, but we are not also using the database that is storing data in the disk. We can use the Redis database to store the data in the database that is in the memory. Can you understand this? When we implement the solution using Redis, you're going to understand it better, okay? Let's move on because we have a lot of things to cover in this course. So another solution we can use Redis to implement is real-time analytics. We can store and process high-speed data streams like user actions, clicks, or transactions. So we can like use the power of in-memory database, in this case Redis, to register, to store data that we collect from the actions of the users, okay, and analyze in real time, right? We can also, with the same structure, we can implement solutions like voting systems that we have to store and display data in real time and fast. We cannot store the data and delay minutes or too many seconds to display the data that was stored. We have to display also almost in real time. So this type of database is perfect for this, okay? So both user behavior operations, we can use collect the data and store to make a real-time analytics, and real-time data display systems, okay, like voting systems, ranking systems, every kind of feature, every kind of product, or every kind of system that we have to display data in real time, store and display, update and display the data in real time. All right, so let's move on. Another one is the message queues, okay? Redis is not a message broker like RabbitMQ or Kafka, okay? It is not. All right, maybe you made this mistake thinking that Redis serves as a message broker. I don't recommend it, but to take our first steps into the message broker architecture, to understand the data flow of pushing a message to a queue through a producer, producing a message to a queue for a consumer to read it and process it one by one, you can use Redis as a lightweight broker. Okay, so you can create like a lightweight broker with Redis in the memory to push your messages to the queue, and as you being a producer and the consumer reading, retrieving, and processing. All right. Again, Redis is not a message broker. You can implement a lightweight broker, like even like emulating a message broker with Redis to understand how these message brokers architecture work, or data flow work. Okay, so that's it. We're going to do this in this course. This right here, as I told you before, is the main use case, because everyone thinks that Redis just only serves for the purpose of caching. All right, Redis is frequently known as a caching database, and I already told you that is not. All right, but the caching layer is one of the most popular solutions that we can implement with Redis. So it will be our main use case, our first use case. We are going to try to implement this, and we are going to understand that although Redis is a in-memory database, non-relational database in memory, for us to have fast access to the data, because it's stored in the memory and not in the disk, we can implement many solutions, and we will implement many solutions as the solutions that I told you before. But as the main use case, the most popular use case is to implement the caching layer of our applications, of one application. This is going to be our main use case. Okay, so shout out to these guys right here in Telesoft. I took this image from Google to use in this class, so make sure you guys check these guys out, because they made this illustration here, and it's pretty clear how the caching layer with Redis work. Okay, so our application, when we want to retrieve data, when we want to access data, instead of going directly to the database and taking 6, 7, 8 seconds or 30 seconds, as I went through the situation a couple hours ago with one of my developers. We had a request that took more than 30 seconds, and we were facing a timeout issue because of this, because the API gateway of that endpoint was configured and has the maximum time of 29 seconds, and our request was taking 35, I believe. So we implemented a caching layer to reduce, and we reduced to 4 seconds, 3 seconds. Okay, in this case that I went through a couple hours ago, it was a real case, but we didn't implement just to increase performance. Increasing performance is pretty good, but in some contexts, if you don't have performance, it won't even work. Alright, because this endpoint, for example, this method, for example, was exposed in a API gateway from AWS, and the configuration of timeout is 29 seconds maximum. Alright, so if our service, our endpoint, our method, anyway, don't have performance, it won't even work. Alright? You may think that it will work like in a lazy way, slower and pretty slow, but work. But it's not this case. Maybe it won't even work because of the timeout configurations. If it works in 40 seconds, but the timeout is 30, it won't work. You won't return the data that you want to return through this endpoint, through that endpoint. Can you get it? So this is one of the cases that requires a caching layer. Okay, so instead of going directly to the database, first we look in the cache. As you know now, implemented with the Redis database. You have to abstract this in your mind. The Redis database is just a database in the memory. The caching layer is one solution that we can implement using Redis, okay? And it's not the only one. We can use Redis to implement another solutions, as I told you before. But the most popular is the caching layer. Okay, so we look in the cache instead of looking in the database, looking into the database. So when we look into the cache and an event that we call cache hit happens, what is a cache hit? Is an event that is returned when the data that we expect is stored in the cache, in the memory. In this case, in the Redis database, inside the Redis database. Is the data here? Yes, it is. So we return. In 2 seconds, 1 second, maybe less than 1 second, we have the data. We have to return the data. We have returned the data. But you can also see a situation when you look at the cache and the data is not there. So you face an event called cache miss, as you can see here, that the guys from IntelliSoft drowned. Okay, drowned, no. Drowned, I believe, is dying in water, right? My English is pretty awful today, but anyway. So cache miss is when the data is not here in the cache, in the database that represents your caching layer, that supports your caching layer. So in this case, you go to the database and look for the data and wait. Right? You have a third flow here, which is prime cache with data. And in this case is when you have a cache miss and you look the data, instead of just returning, you populate the cache with this data. Okay. In fact, there are many techniques to keep your caching layer up to date. And maybe you are wondering now, if I have to populate the cache and I have to apply techniques to keep my cache up to date, why the hell do I have to use a database? Why can't I use the Redis database itself as my primary database? And the answer is you can, but you should not. Because when you store the data in the memory, one issue that you are going to face is the high risk of losing this data. Of course, you have techniques to avoid this, but you are going to increase your costs, all right? Because memory is pretty faster to access, but it's also expensiver than disk. Data storage in disk, data access in disk databases, in disk-based databases are slower but are cheaper. Okay, data storage in in-memory databases are faster, but it's also expensiver. So we have to find a healthy balance between storing data in the caching layer through a in-memory based database and storing data in a disk-based database. We have to find this healthy balance, because if you go just for one side, you are going to have an application that is way faster than the others. It's pretty fast and light speed level, but it's too expensive to support, to maintain. Okay, and the other side, you're going to have an application that is cheaper to support, to maintain, but is way slower, maybe too slow for the user, or maybe even, as I said before, too slow even to work, right? Some endpoints, some methods, some services, depending on how much time it takes to return the data, just throws a timeout error and does not return the data, so it doesn't work. All right, so these are the main things you need to know about Redis to get started. Okay, so in this course we're going to implement many solutions using Redis, and our main use case is going to be the caching layer. Okay, because is the, in my opinion at least, is the most popular solution that we can leverage from Redis, I believe, take advantage from Redis, and in my opinion is the perfectly balanced scenario when you to use a database in memory and a database in disk. Okay, as you can see in this picture right here. Alright, so that's it for today. I hope you enjoyed this lesson, and I hope you learned a little bit more about Redis. Alright, see you on the next class.